Just making sure this video isn't like I decided to redo this one. Okay, so 7.2 hypothesis test. So in this one, we're going to be talking about using finding p-values, using p-values to test a mean. So right here, this is going to be part 1 of, and this is part 2. So I've split this lesson into 2 sections again. Part 1 is what we're going to be doing. Part 2 is going to be finding critical values in a normal distribution, find rejection regions in a normal distribution, and then use the rejection regions for a z-test. That's going to have its own video and everything done. For significance value, then you fail to reject the null hypothesis. So the way we wrote this last time was we had p less than or equal to alpha in a circle, where alpha is our significance level. So then you asked yourself, this was your question, is p less than or equal to alpha? If your answer was yes, then you were told to reject the null hypothesis. However, if your answer was no, then you are told to fail to reject your null hypothesis. P stands for the probability that the null hypothesis is correct. So if your probability is really low of your null hypothesis being correct, and it's falling behind, then you don't want to go with a low probability. You want to go with a higher one, which is why the significance value and this p-value come in handy. So if you have a low significance value, then you're a yes, and you reject. If that's not correct, and your percent of your null hypothesis being correct is greater than your significance value, then you are a no, and you fail to reject. So when you fail to reject, then you're going to be claiming that null hypothesis. Alright, so simple examples to start off with that. So if your p-value of a hypothesis test is 0.0302, what would your decision be? So this means that p is equal. So remember, this is your question. This is your question to be asked. So if your significance level is 0.01 and your p-value, your question is 0.0302. Is 0.0302 less than or equal to 0.01? Well, I want you to know, with decimals, you start with the next value. So we have 0.0 and 0.0. So those are both equal. So you go to the next decimal value, which would be 1 and 3. And you ask yourself, you can stop right there. Is 0.01 less than or less than 0.03? You add. This is where your question comes in handy. Is 0.0302 less than or 3 is greater than 1? So this is going to be a no. If it's not, then you can cancel that out. So we're going to fail your null hypothesis. Bam. Simple as that. This told us that this was not correct. Now, let's say our significance level is 0.05, then using that same p-value, 0.0302, is 0.0302 less than or equal to 0.05? Well, looking at this one, we have 0.05, we have 0.03. 3 is less than 0.05, so yes, this is correct. Yep. So, we're going to reject the null hypothesis. We're going to kick it to the curb. It wasn't greater than our significance level. So, you'd rather go with something that, like, if you want something to work in your favor, you want the higher outcome, not the lower one. Okay, now talking about p-values. That's when your p-value is given. If you need to calculate, first, most of the time you're going to have to calculate standardized test statistic, which we'll talk about in a minute. Then you will need to find the corresponding area. The corresponding area is going to be your p-value. Depending on what kind of side tail test you have, so like if you're left, then your p-value is equal to the area in the left tail. If you are right-tailed, then your p-value is equal to the area in the right tail. On the other hand, if you are a two-tailed, then your p-value is going to be equal to 2 times the area in tail of test statistic. What this means is if you're a two-tailed test, and normally you'll be shaded, either it'll tell you to do on the left or on the right. You'll either shade to the left or you'll shade to the right. You're going to find the area of the shaded region using either left or right in your calculation, and then you're going to multiply that by 2. So we'll actually have an example. So this first example says, find the p-value for a left-tailed test with the test statistics of z equal to -2.15. So here is your z-score, -2.15. Drawing my standardized normal curve. I'm now going to plot z equal -2.15. So -2.15 is right about here. So once you've plotted it, and you know it's a left-tailed, you shade into the left. Now, what this left tail tells you is that your area, your p-value, is going to be equal to the area in the left side of the tail. So we have to find the area to the left. Remember that this goes off to -infinity, which we write as -1e99. So, using your calculator, or the handy dandy website that I gave you, hitting seconds bars. So I'm going to write that down actually. And then number 2, normal CDF. Step moving. Number 2, normal CDF. Make sure your lower bound is -infinity. If you're a left-tailed test, your lower bound is going to be -infinity. And then remember, you can hit that -infinity by hitting second and this comma, which has 2 e's above it. Now your upper bound is going to be your z value of -2.15. Your mean should stay at 0 and your standard deviations should stay at 1. Now, some of y'all's calculators might not go into this table. It might just straight up say, like, when you hit normal CDF, it'll normal CDF and it'll open parentheses. So if it does that, I'm going to write it down here. If it opens parentheses, then you just got to type in your lower bound, your upper bound, make sure it's 0, 1, and close your parentheses. And remember, you can hit the commas. You can find the commas by hitting the comma button. So you'll put in whatever your lower bound is. In this case, you would put in -1e99, comma, -2.15 for your upper bound, comma, 0, comma, 1. Close and hit enter. And this gave you that your area equals 0.01578. I believe that if you use the website I give you, it's going to give you 0.0158 because it just rounded 1 decimal place earlier. So because your p-value is equal to the area, then you just found your p-value. Bam. So on these, our p-value is going to be equal to the area of the shaded region. Now then, this other example. Find the p-value for a two-tailed test with a test statistic of 7.15. Yeah. 0, 1, 2, 3, -1, -2, -3. By the way, guys, when I label these and I draw my own standardized curve, y'all know my curves don't come out the best. And I just kind of plot 0 in the middle and then try to make equal distances between my next couple of plots. It's not perfect, but it's the best I can do. Just don't try and like tell me that like 1 is right here and then 2 is all the way over here. Nah, just try to make it look realistic. Like that's all I ask. Okay, so in this case, our z-value is a positive 2.15, which is going to fall about right here. And we are a two-tailed test. But when you do a two-tailed test, you're either going to have the left area shaded or you're going to have the right area shaded. Since your z-value is on the right side, we're actually going to shade in this right side and then find the area to the right side of the test statistic. So this one is going to be a right-tailed test. The only difference between this one and the left-tailed is you are in your normal CDF. Now, instead of us going from -infinity to a number, our smallest number, you go from left to right. So if you're pushing this pencil, you're going to hit 0.15 first. So that's your lower bound. Is the first number you hit 2.15. Your upper bound, girl, there ain't no stopping on this one. So it's 1e99, a positive infinity. Your mean should be 0 and your standard deviation should be 1. So hitting it the other way, if you had to, it'd be normal CDF, open parentheses, you would put in 2.15, comma 1e99, comma 0, comma 1, close parentheses. And then you hit enter. So, my calculator will do this. Second bar, number 2. Okay, make sure my normal one is 2.15. Then I'm going to hit 1 second comma to get the E99, 0, 1, paste. And this one's going to give me that my area is equal to 0.01578. But if you remember, it told you right here that if you have a two-tailed test, your p-value is going to be 2 times the area. So then once you have your area, to find your p-value, you got to do 2 times the area, which is going to be 2 times 0.01578, which is going to be 0.03156. So then p equals 0.03156. Bam. Okay, so the formula for the test statistic is actually that your test statistic, your z-value, is your sample mean minus your hypothesized mean divided by your standard error. So you can use z-tests for means when the population is normal. And we know the population standard deviation, standard sigma. So if you have a normal population, then you can use your z-test for the means that are given, and you know you need to be given your normal, your population standard deviation, so sigma. So the more advanced formula for the test statistic z for a z-test for means would be that your z is to your sample mean minus your hypothesized mean divided by your standard deviation, population standard deviation, divided by the square root of your sample size. So X bar stands for your sample mean. Mu stands for your hypothesized mean. Sigma is your population standard deviation. And N is your sample size. Alright then, so please note. Let me get it out. Right here where it says that if your sample size is greater than or equal to 30, you can substitute your sample standard deviation for your population standard deviation. But you have to have a sample size greater than 30, greater than or equal to 30. If you have anything less than 30, then you have to use your population standard deviation. Now, p-values and z-tests. So there's 7 steps for using p-values for z-test for mu. The words are going to tell you what you need to do, but the math is the actual work. So when you're doing this on as a problem, you need to do the math part. But the words part will tell you what everything means and what you're doing. Okay, so your first step is to write your claim mathematically. You also need to identify, once you have your claim, your null and alternative hypothesis. So we're looking for HO and HA. Your null hypothesis and your alternative hypothesis. Please remember that your null hypothesis, it's just a hypothesis, a statistic hypothesis that includes equality. And your alternative hypothesis is another statistics hypothesis that does not include equality. So it's the it's the complement of your null. So then your second step would be to identify the level of significance. So that's where you state what is your alpha equal to, which your problem should normally tell you what alpha is. So it'll say alpha, your alpha equals a number. Now then, after doing that, then you need to find your z-test. Oh, you need to go up down to number 3. Step number 3 tells you to calculate the test statistic. So that would be the z equal to the sample mean minus the hypothesized mean divided by the population standard deviation divided by the square root of your sample size. Then number 4, you need to calculate the area of the test statistic. So that's using the second vars, number 2 normal CDF. And if you are on a calculator, again, it's going to pop up normal. If you're on an older version, normal CDF, you need to put your lower bound, your upper bound, your mean and your standard deviation, which should be just 0 and 1. If you have a more updated version, then it'll pop up that big column and it'll tell you to input your things, and then it'll do the rest. And your 5th step is the area to find your p-value. So I'm going to rewrite this again. Alright, if you are left-tailed, this is on a previous page, but just in case, we're going to redo this. Then your p-value is equal to the area to the left. P left-tailed p-value is equal to the area to the left. I'm going to start right here, to the left of your test statistic. If you are a right-tailed, I'm writing a little bit smaller so it'll fit in this spot. This is why I wrote number 4 a little bit too high, so I could write 5 a little bit too high. So then your p-value is equal to your area to the right. Of your test statistic. And then if you are a two-tailed, then your p-value, yes, p-value is equal to 2 times the area of the test statistic. I'm going to write that one right there. Alright. That just depends on what kind of a test you are. Now once you figure out what your p-value is, so once you have your p-value, then you need to make a decision based on comparing p-value to your significance level. So when doing that, you're going to do one of two things. You're going to reject, or you're going to fail to reject. So you're going to reject if your p-value is less than or equal to your significance value, and you will fail to reject if your p-value is not less than or equal to your significance value. Then your last step is once you have rejected your null hypothesis, or you have failed to reject your null hypothesis, you need to interpret whichever of the two decisions you make in context of your problem, which the problem is going to be the claim. Alright, so doing an example, Papa John's Pizza claims they can deliver pizza within delivery area in 30 minutes or less. 35 deliveries are randomly selected and the sample mean is 28.8 minutes with a standard deviation of 4.1 minutes. At a significance level equal to 0.01, is there no convincing evidence to support their claim? So we're going to take, so they gave a claim. They say we can deliver pizza in the area within 30 minutes. So then less than or equal to 30 minutes. But we decided let's test that. So we randomly selected 35 deliveries to figure out what was their average time. And so we found that in our sample mean, we got 28.8 minutes. With the standard deviation, because sometimes you're a little bit off. And then now we're going to say do we have enough evidence with our selected mean to find that their claim is correct? So we are testing their claim. That is what we are doing, is we are trying to find evidence to support their claim or to reject their claim. So, your first step of this, wrong paper. Your first step is to write your claim mathematically and identify the null and alternative hypothesis. And then I'm going to go ahead and do that. So your claim is in the first sentence. You have claimed. So here we go. Our claim, they can deliver pizza within delivery area. So all of this is telling us that we are actually looking at the mean. In 30 minutes or less. This in means include 30 minutes. So there's the claim. So because our claim includes equality, it will go into the alternative hypothesis. And then to write, or it goes into the null hypothesis because it includes equality. Flipping the sign, taking off equality, we have our alternative hypothesis. Now your second step says to identify significance. Alpha equal to 1. That's where you say alpha equals 0.01. It already told you the area of significance in this case. So flipping over to the back, this is finished out back there. Pulling this down a little bit. Your third step. Bam. Calculate your test statistic using z equal to your formula. To actually do this, we need 4 things. We need to know what is our sample mean, what is our hypothesized mean, what is your sample size. So continuing to read, it says 35 deliveries are randomly sample size. Sample mean is 28.8 minutes with a standard deviation of 4.1 minutes. Now your hypothesized mean is going to be the number from your claim. So then using these inside of the formula, z equals your sample mean minus your hypothesis mean divided by your standard deviation divided by the square root of your sample size. So we had 28.8 minus 30 divided by 4.1 divided by the square root of 35. Which once you calculate this comes out to be negative 1.73. Okay, that's your z-value. Now, your step number 4 states that you need to calculate the area of the test statistic. So, either using your second verse number 2 on your calculator, or using the website I have provided for you. Either of the two will help you find out that your area is equal to 0.9582. So that means that your p-value is equal to 0.9582. You can tell this part because if you had this drawn, and since your z is negative 1.73, when you go and you plot it, you go over to your null hypothesis and your alternative hypothesis. And looking at the alternative hypothesis, we have an arrow pointing to the right. but is a greater than, that is a right-tailed test. So then we would have shaded the area to the right of it. And this would have told us to do a right-tailed test. And your right-tailed test are we on number 4? Okay, this is step number 5, actually. Step number 5 says using the area to find your p-value. So we did a right-tailed, so p-value is equal to the area to the right of the test hypothesis. We found the area to the right, and p is equal to 0.9582. And this was, I already said it, you either use web or you use second vars number 2 normal CDF, which I wrote it down over here, and how to do it. And then that was step number 5. Step number 6, make a decision based on comparing the p-value to your confidence level. P less than or equal to alpha. Is 0.9582 less than or equal to 0.01? Because that was your level of significance. And this is your p-value. Well, looking at the first one, 0.9 is definitely bigger than 0.01. So, nope, that is not correct. Now, recall that if you say no, then you're going to fail to reject your null hypothesis. So, our decision is that we fail to reject it. So, if you recall, your null hypothesis is that the average, that your null hypothesis is actually your claim in this case, that Papa John's can deliver pizza within delivery area in 30 minutes or less, so that the average delivery time is less than or equal to 30. So part number 7 said to interpret your decision in context of the claim. In context of our claim is that we have sufficient evidence and will not reject the claim that the mean delivery time is less than or equal to 30 minutes. So when you fail to reject your null hypothesis, when you are writing your last sentence, which is your interpretation, then you have enough evidence to not reject the claim and then state what your claim was, that the mean delivery time was less than or equal to 30 minutes. So that means, guess what? You didn't reject it, you accepted it. You say, okay, Papa John's, I have done my math, I have looked it up, and man, you are not lying. You can deliver pizza within 30 minutes or less by the sample mean. The evidence, your evidence, is that sample size that you took. Because you don't always just believe what somebody tells you. Like, most of the time, like, somebody might be like, okay, well, you know what? Maybe you worked for maybe you worked for Pizza Hut, and you're like, you know what? Let's try and figure out if this is actually correct. Because if they're not correct and they're lying to their customers about their delivery time, then if you worked for Pizza Hut and you found out they were lying, then be like, oh man, look at this, they're lying. Let's show everybody this, and then Papa John's will look bad, and you're like, well, but look at ours, and you could look better. I'm not sure. Everybody does things for a different reason. Maybe when somebody tries to claim their pizza times, another company like that will double check it, will like go through and make sure everything's correct and do other sample size, so there's no lying or anything like that.